All right, hi folks, this is Larry Mussolino. I wanted to record a video for Module 3 in STAT412. I wanted to do a few of the My Lab's homework problems to help you get started. And in particular, I want to do a few examples that involve some integration methods because you may be a little rusty on integration, maybe you haven't taken a calculus course in a while. So let's do a few examples here. So here's one that says the shelf life in days for bottles of a certain medicine is a random variable having this density function shown below. Find the probability that a bottle of this medicine will have a shelf life at least 100 days or anywhere from 80 to 110 days. So when you have a probability density function like they're giving us, and you want to know a probability, what we're trying to do is find the area under this probability density curve. You probably remember this from working with the normal distribution, right? You remember if you were working with the normal curve and you wanted to know a probability, you ended up finding the area under the curve between certain bounds, right? For example, let's say this is IQ scores. And someone asked you find the probability that someone has an IQ score between 80 and 90, let's say. Well, this would be the normal, assuming the IQ scores are normally distributed, you would be asked to find this area under the curve between 80 and 90. So that's really what they're asking us to do here. So imagine we have some probability density function. I'm just going to draw any function like this, let's say. And part A is asking us a shelf life of at least 100 days. So what we're measuring here is shelf life. And at least 100 days means 100 or greater. So let's say 100 days is here. We're being asked to find this area under the curve from 100 all the way over to, really this is going to infinity, right? Well, to find the area under a curve, that is the integral in calculus. So to find this probability for part A, what I'm going to do is integrate this function from 100 days to infinity. And the function is 20,000 over x plus 100 to the third. The first thing I'm going to do is I'm going to take this constant 20,000 and move it out in front of the integral symbol. I'm allowed to do that, and it makes the integral just a lot easier to work with. The other thing I'm going to do, I forgot to put a dx here. The other thing I'm going to do is I'm going to move this expression in the denominator up to the numerator. So that's going to make it x plus 100 to the negative 3. Remember, when you have an expression in the denominator and you want to move it up to the numerator, it flips the sign of the exponent, right? An example of that, 1 over x to the 5, I could write as x to the negative 5. So we're going to set up the integral like this, and this is going from 100 to infinity. All right, so I need to work out this integral. Well, you know, there's a couple of ways we could do this. One way is we can use a method called integration by substitution. So to make this a little easier, I'm going to use an integral formula that looks like this. The integral of x to an exponent is x to the n plus 1 over n plus 1. Let's do an example here just to get started. How about the integral of x to the 4 dx? Well, the rule says to find the integral of this function, you add 1 to the exponent and you divide by that same quantity, 4 plus 1. So this is x to the 5 over 5. All right, so that's what we're going to do here. But first, we want to do a u substitution, it's called. So I let u equal the expression in the parenthesis, x plus 100. And then I'm noticing if I take derivative of both sides, du dx just equals 1. Because the derivative of x is just 1. That means du equals dx in this example. The reason I did that is I want to convert this into an integral with u's just to make it easier. So what I'm going to do here is replace what's in the parenthesis with u, so it's going to be u to the -3. And because dx is equal to du, I'm going to replace dx with just du. The reason I did this is now the integral looks like this rule up here. By the way, we call this the power rule. So now our integral looks like the power rule. So let's write it out. It's going to be 20,000. The integral of u to the -3. So I'm going to write that as u to the -3 plus 1 over -3 plus 1. The only reason I'm using u substitution is to get the integral to look like this format so that I can match it up to this power rule. All right, let me keep going. So this is going to be, and by the way, we always have to, we're going to evaluate this from 100 to infinity in the end. So this is going to be 20,000 u to the -2 over -2. But 20,000 over -2 is -10,000 u to the -2. Well, I just used u as a temporary substitution. Let me go back and replace u with x plus 100. So really this integral worked out to be -10,000 x plus 100 to the -2. And of course, I'm going to be evaluating this from 100 to 50. All right, to make this a little easier, I'm going to move this expression down to the bottom of a fraction. So this is going to be -10,000 over x plus 100 to the +2. All right, and we're going to evaluate this from 100 to infinity. Well, if you remember from calculus, the way you evaluate this is you plug in the upper limit first. So I'm going to type in -10,000 over infinity on the denominator. It's really infinity plus 100 squared, but of course that's just infinity. And then you subtract when you plug in the lower bound. So I'm going to be subtracting -10,000 over 100 plus 100 squared. Well, any fraction with an infinity in the denominator is 0. So that's just a 0. And what I'm left with, I'll write it over here, is subtracting a negative. So that's a positive. So this is 10,000 over 200 squared. And I'll just work this out on my calculator. 0.25 is what that works out to be. So the probability of a shelf life at least 100 days is only 0.25. All right. Let's do the same item for part B. And part B, we could take a little bit of a shortcut because we've already worked out the integral to be this quantity right here. Let me highlight this here, maybe in green. So we've worked out the integral to be this. The only thing we're going to do for part B is change these limits. So let me erase a little bit here so we could do part B. So part B is asking us, what's the probability that the shelf life is going to be from 80 to 100 days? So for part B, this probability is going to be the integral from 80 to 110 of the same density function, 20,000 over x plus 100 to the third. Well, I'm not going to work all this out again because it's going to get me to the same place. I'm going to end up with -10,000 over x plus 100 squared. The only difference now is the limits are from 80 to 110. Well, again, to work out a definite integral like this, you plug in the upper bound first. So this is going to be -10,000, 110 plus 100 squared, minus, now you plug in the lower bound. This is going to be -10,000 over 80 plus 100 squared. And this is a job for my calculator. I'll work this out on my calculator and I'll get 0.08. So there's only about an 8% chance that the shelf life of this medicine is going to be going to last from 80 to 110 days. Okay. So folks, again, just to summarize what we did here, if you want to know the probability for a continuous probability density function, you're really finding the area under the curve. But the area under the curve is the integral. And so we're going to need to use some calculus methods here. The basic calculus method for integration is this power rule. Okay? Folks, again, if you're a little rusty on integration, you might want to go back to a calculus book or check out some videos on YouTube or go to Khan Academy. There's been many videos there on doing basic integration like this. Okay. Folks, I want to do another homework problem here from the week 3 homework in my lab. So here's one that asks you to look at this density function. And looks like this is the number of hours in units of 100 hours that a family runs a vacuum cleaner. Find the average number of hours that a family runs their vacuum cleaner per year. Well, when you have a density function and you want to know the average, the formula says take the integral, really it would be the integral from negative infinity to positive infinity of x times the density function like this. So that's where you find the average of a function like this. So we want to figure out this average. All right, well, this is going to be a little messy because this function is broken up into 2 parts. It's this function for this interval, and then it's this function for this interval. All right, so why don't we get started here? So the average is going to be taking the integral, and I'm going to leave these limits out for right now. I'll come back and put the limits in a little later, but I'm going to leave them out for right now, just to make things a little simpler. So for this part of the function here, let's call this part A and part B. So for part A of the function, we're going to take the integral of x times 3/4 x dx. And then for part B, it's going to be integral of x times the square root of 3 minus 3/4 x dx. All right, let me just write this out a little, clean this up a little bit. So this is going to be the integral of 3/4 x squared dx. This was part A. And part B is going to be, I'm going to break this up into 2 parts. I'm going to write this as the square root of 3 x dx minus the integral of 3/4 x squared. Okay, so this is part B here. The reason I'm breaking it up into 3 integrals is I want to evaluate the limits here, and it's going to be messy with these limits. So if I can break this up into 3 parts, it's going to help me kind of organize the calculations. All right, so let me go ahead and work out each one of these integrals. Well, remember, there's the power rule. It says you're taking the integral of x to the n dx. You add 1 to the exponent and divide by that same quantity, n plus 1. All right, let me do this integral right here. So this is going to be 3/4 x to the 3/3. Let me do this part right here. This is going to be the square root of 3 x squared over 2. And let me do this last part here. This is going to be 3/4 x to the 3/3. And of course, I have to evaluate each one of these per the limits that are given to us. I'll plug those in just a second. Let me just clean this up one more time, because I'm going to write this as a denominator of 12 here. So this is going to be 3/12. but that's just 1/4. So I'm just going to write this as 1/4 x to the third. Let me stay with the same color coding here. So let me keep this one in red. So this is going to be 1/4. Again, I multiplied this 4 times 3. That's a 12. 3 over 12 is 1/4. So that's 1/4 x to the third. And let me plug in the limits here. Our limits are going to be from 0 to 2 square root of 3 over 3. Okay, because I'm using these limits right here for part A. All right, let me go to the next part right here. So this is going to be the square root of 3 over 2 x squared. And the limits here are 2 square root of 3 over 3 on the bottom and 4 square root of 3 over 3 on the top. So these are messy limits, but let's keep going. And the last one is this guy right here. Again, I'm going to multiply this 4 times 3. That's a 12. Then 3 over 12 is 1/4. So this is going to be minus 1/4 x to the third. And the limits here are again 2 square root of 3 over 3 and 4 square root of 3 over 3. All right, this is messy, but let's keep going. Let's work out this red integral first. All right. Well, I'm going to plug in this upper bound. So it's going to be 1/4. And then this is going to be 2 square root of 3 over 3 to the exponent 3. All right. Let me work that out. And of course, the lower bound is 0. But when I plug 0 in, that just gets me a 0. So I'm not going to bother plugging in the lower bound. All right, let me work this out. Let's see here. 2 to the third is 8. The square root of 3 to the third. So the square root of 3 to the third. That's the square root of 3 times the square root of 3 times the square root of 3. Square root of 3 times square root of 3 is 3. So this is 3 square root of 3. So I have a 3 square root of 3. And on the bottom, I have a 27. All right, I can clean that up in a little. I'll clean this up in a little bit. But let me keep going to the blue integral. All right, so here's the blue integral. I'm going to plug in this upper bound first. So we have the square root of 3 over 2. And I'm going to plug in the upper bound. It's 4 square root of 3. Actually, let me do it. Let me do it up here on this row. So I'm going to do it here. Yep. So we got the square root of 3 over 2. And I'm plugging in this upper bound now. So I have 4 square root of 3 over 3 squared. And I'm going to subtract the lower bound, which is 2 square root of 3 over 3 squared. All right, let me come down here and clean this up a little bit. Let's see here. 4 squared is 16. The square root of 3 squared is a 3. And the bottom of 3 squared is a 9. All right, let me come over here. A 2 squared is a 4. Square root of 3 squared is a 3. And on the bottom of 3 squared is a 9. All right, I'll come back and clean that up. But let's do the green integral here. So the green integral is minus 1/4. And now it's x to the third. So I'm going to plug in this up here. So that's going to be 4 square root of 3 over 3 to the third. Minus, I'm going to plug in this lower bound. So we have 2 square root of 3 over 3 to the third. Yes, this is messy, but you know, as long as you kind of take it one step at a time and stay organized, it's not as bad, I think, as it seems. All right, you might disagree, but let's keep going. All right, let's do this. 4 to the third is 64. The square root of 3 to the third, we work that out over here. That's a 3 square root of 3. And on the bottom, 3 to the third is a 27. Let me come back here. 2 to the third is 8. The square root of 3 to the third is 3 square root of 3. On the bottom, 3 to the third is a 27. All right, let's try to clean this up and we can finish it up. Let's do it. So let's see, here I have an 8 over 4. So I'm going to change that to be a 2. Here I have a 3 over 27, so I'm going to put a 9 on the bottom. So it looks like what I have there is 2, oops, let me stay color coded here. So this is red. Let me draw this in red then. So what we ended up, so we're just working out this guy right here. So it looks like what we have is 2 square root of 3 over 9. All right, let me come over here to the blue part. Let's see, here we have a 16 times 3, that's 48. And a 4 times 3 is 12. So that's 48 minus 12. Well, that's 36. So what we got there is square root of 3 over 2 and a 36 over 9. All right, come back and clean that up in a second. But let's go to the green. So for the green one, let's see here. We have 64 times 3. What is that? 192, I think. Yeah. So that's 192 square root of 3. And 8 times 3 is 24. So 192 subtract 24. I think that's 168. So we have 168 square root of 3 over 27. All right. I'm going to simplify it one more step. I could go to my calculator now, but let me simplify it one more step because I'm seeing here 36 over 9. This 36 over 9 is 4. And then this 4 divided by 2 is a 2. So I think this is just 2 square root of 3 for that one. All right, let me come back here to the green. Let's see here. I have a 168 over 4. That's a 42. So this is going to be 42 square root of 3 over 27. I think I'm going to go to my calculator now. I'm going to type this all into my calculator. If you do, I think this works out to be 1.15 on your calculator. But remember, this is units of 100 hours. So to get my final answer here, I'll write it up here for the final answer. I have to take 1.15 times 100. So that's 115 hours. That's the average number of hours per year that a family runs their vacuum. Okay, folks, this is messy integration for sure, but the starting formula is when you want to know an average, take the integral of x times the probability density function. And the tricky part of this is we really had to break this up into 3 different parts. And I called it part A. And, here's part B. I broke it up to 3 different integrals to make it kind of easy to work through. And got to be careful here with all of these, square roots floating around. All right. Hope this is helpful as you're working in homework 3. Maybe I'll try to post another video with a few more worked out examples. All right. Thanks, folks.